Hello everyone, my name is Hala Jasim from University of Baghdad, College of Science, Department of Remote Sensing and GIS, in the Seismology and Spatial Data Analysis Lab. Today, I will present our project titled Automated Seismic Detection Algorithm Applied for Iraq's Mesopotamian Seismological Network. This project prepared for the International Conferences on Digital Technology Driven Engineering 2025. This work was completed with my colleagues Professor Dr. Loay Edward George, Assistant Lecturer Sinan Mahmood, Dr. Enas Hassan, and Assistant Prof. Dr. Najah Hassan Abd. To begin, we must talk about Iraqi location. Iraq is located on an important tectonic boundary between Arabian plates and the Eurasian plates. The region, especially the Zagros Fault thrust belt, have a moderate to strong earthquake activity. In spite of the Mesopotamian plain has a lower seismic activity, there is a small earthquake and the hidden faults that show that the continuous monitoring is still important. So, for this reason, the Mesopotamian Seismological Network was created to improve the local earthquake detection across central and southeastern Iraq. In this study, we proposed an efficient automated method to pre-process and detect seismic signals. We began by removing DC offsets to stabilize the waveform baseline. Next, we monitor the signal energy by calculating both short-term and average energy values. Using an adaptive threshold, the system identifies possible seismic activity while ignoring weak or irrelevant noise. Finally, we apply time window filter to separate real earthquake signals from short noise signals. The overall system procedure consists of 5 stages: pre-processing, which converts SAC file to CSV file. The SAC file came from the stations. Then DC offset and baseline correction using long-term average. Adaptive thresholding to identify potential seismic activity. Then we filter out transient signal or noise using short-term average. The final stage was the event arrival time identification. The pre-processing stage includes reading the header information and the samples. For the header information, there is a station name, station location, the start time of the event, sample interval, and the total number of samples, while the CSV file will contain each sample and its magnitude. After complete the pre-processing, the final result will be the original signal shown in the figure below. In the previous figure, we can notice that there is a deviation for all samples from the zero line. So the next step was correcting the baseline. This step is unimportant because even small offset can affect energy calculation and reduce the accuracy of detection. By removing the DC offset, we ensure the waveform is properly centered and corrected for the further analysis. This step done by computing the long-term average. First, we take the absolute value for all sampling, summing them and dividing the sum by the number of samples. The long-term average then will be subtracted from all samples, so the correct signal will be shown in the figure below. Then we apply a full wave rectification to convert all amplitude values into positive number, which helps in calculating energy more reliably. We then use an adaptive thresholding. The algorithm measures the energy of the rectified signal and automatically chooses a threshold that separates noise from the real seismic activity. The threshold depends on the standard deviation of the sample and a pre-tested and defined factor. Signal binarizing is the following stage. After we computed the threshold, we will compare each signal sample with the predefined threshold. If it is higher than the threshold, we keep it. If not, we set its value to 0. After binarizing the signal, we then apply short-term average method. This method uses a slide window to scan the binarized signal segment by segment, and for every segment or for every window size, the algorithm counts how many number of samples are above the threshold and how many number of samples below the threshold. This ratio helps to determine whether the seismic event is presented in that area or not. If the number of samples classified as 1 is large, then this area contains the seismic event. If the number of samples classified as 1 is small, then this sample may be noise or transient signal. The final result of the detection algorithm shown in this figure. After we filter out the segment or the window size that contain the noise or irrelevant signal, only the seismic event will be kept. So we count the start of the area that contain the ones and set it as the arrival time of the B wave. This example shows the earthquake on 6 June 2021 near the Iran-Iraqi borders. The algorithm successfully identified the seismic phase and separated the event from the background noise, showing the effectiveness of our automated method. A second example of another station shown in this figure. The station of La Amara shows the original signal also had DC offset from the 0 line. Then we correct the signal, convert it to positive, and binarize the signal. You can see in this binarizing signal there is a noise and there is the area that contains the large number of ones. So the final results filter out the noise and transient signal and keep only the area that contains the seismic event. In this figure, the 8 station shown in the same axis to confirm that the arrival time are correctly computed for all stations. This map shows the arrival time for each station to the seismic event, which is the 6 June 2021. That seismic event with a magnitude 4.3 in Iran-Iraq border region. In this slide, we compare the results of our method with the results of ISC catalog results. You can see there is a very few differences between our method and the ISC catalog, time. Finally, we use two more earthquakes to show the efficiency of the proposed system in different scenarios. These earthquakes had different magnitude and different number of stations. It is worth noting that the more stations recorded the earthquake, the more accurately the arrival time could be determined. Thank you for listening. I am happy to answer any question or discuss idea how to improve this automated detection method.